Hello, this is another example where you have to find the lengths of sides where three coordinates are given. So once again, it's coordinate geometry, and then the next three questions you will see are based on your geometric knowledge. Okay, so let's start with the beginning. You are given 3 points. Remember to always make a sketch, okay? Draw your X and Y axis, plot your 3 points, and join them in a straight line. So immediately, people, if you look at this drawing, you can see that this angle is quite possibly a 90-degree angle. So we are working with a right-angled triangle. Okay, so that is always a good idea. You may not use a graph to actually prove a certain statement, but it will help you to actually understand the question and to answer the question algebraically. Okay, so for the first question, which asks the length of PQ, QR, and PR, so these are the line segments, I'm not going to go through. Remember, we use basically Pythagoras, okay, where the side in this case is PQ is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, this formula you must just simply know, right? Then I taught you to write down your points. Okay, P is 0 minus 5 and Q is negative 2, 1. Okay, and then we make this one x2, y2, right? And this one we make x1, y1, right? And then you simply substitute your values, you calculate, and you get the square root of 40. Similarly, QR is done like that, and similarly, PR is done like that. Right, if you don't understand this, please go back to the first video that I posted, which is on the length of a line segment. It is a video consisting of 2 parts, which explains this whole calculation of the line segment. So I will not repeat that. But now, if we look at question 2 or B, it says, show that triangle PQR is a right-angled triangle. Now remember, Pythagoras is only true for a right-angled triangle. So if the two short sides, so PQ squared plus QR squared, that's the other two short side, is equal to the longest side squared, that's Pythagoras, then if we can prove this, then we can prove that this is a right-angled triangle. So firstly, take your PQ squared plus QR squared, use your answers from the top, which is 40 squared, or square root of 40 squared, plus the square root of 160 squared, and if you calculate that, you get 200. Right? Then PR, which is your other side, take PR, which is the square root of 200, and you must square that because you've got PR squared, then you get 200. So in this case, the left-hand side equals the right-hand side. We calculated this as 200 and PR as 200. So in this case, Pythagoras is correct, right? And therefore, we can prove that the angle PQR is 90 degrees, right? I hope you follow that. So the point here is you must show that this is a right-angled triangle. You must show that Pythagoras is correct. So if you would get the left-hand side being another answer than the right-hand side, then obviously it is not going to be a right-angled triangle. All right, the next question, find the perimeter of triangle PQR correct to 3 significant figures. Now remember, perimeter is the distance around, so we must calculate PQ plus QR plus PR. Okay, very simple. We must add those side lengths. So triangle PQR is PQ plus QR plus PR. We use our answers from question 1, square root of 40 plus square root of 160 plus square root of 200, and then you calculate your square root, which gives me an answer of 33.1 units, correct to 3 significant figures. All right, perimeter, distance around. So we must simply add up all the sides and use your answers from question A, substitute them and calculate. All right, then the last one says you must find the area of triangle PQR. Now, because we've got a right angle triangle, we can use the basic formula for the area of a triangle, which is half base times height. And then remember, importantly, people, that the base, if QR is the base, then the height must always be the perpendicular height. So it must be QP. Right, so we start by using the standard formula, which is half base times height. Half, we chosen QR as base, okay, QR, and then QP as the perpendicular height. Okay, and again, you've got the half. Use the answer to QR, which is 160 in the square root, right? Times QP, which is the square root of 40, multiplied by the square root of 40. And again, put this into your calculator, and you will get an answer of 40 units square. Okay, so this is a very nice example where it shows you where in coordinate geometry the algebra and the geometry part fits together.